One day, this kid is at his house just minding his own business, and all of a sudden, smoke fills up his room. He thinks there's a fire. So he goes to his door to try to leave. Once he gets to his door, he realizes that his door locking system is broken, and he doesn't know why, so he tries to figure out and sees a resistor is missing.
This is what our circuit's supposed to look like. You can see this is the resistor that we're missing. It's supposed to be 3 ohms, but we don't have it right now, so we don't have it. So we're gonna solve this circuit using Kirchhoff's loop, which is a method for solving circuits with more than one battery. So we have one here, here, and here. So the first step in doing Kirchhoff's is you're gonna wanna make loops for each battery. So we're gonna have one loop here, which we're gonna call A, one loop here, B, and then the last loop here is loop C. Okay. Next thing we're gonna do is identify the currents that we have in each branch. So the current right here, we're just gonna make it easy and call I1. And that current goes through here. We're gonna call this current coming down this branch I2. So let's make I2. So since the current from I1 is breaking off right here, the current in this branch up here is I1 minus I2. We're gonna call this current I3. And that means that this current running through here is equal to I1 minus I2 minus I3. So this is gonna run around here. When it meets up with I3, then the current running through this part is just I1 minus I2, and then I2 adds back in here and makes this part just equal to I1. So Kirchhoff's loop, when you go through each one of the loops and then back to where you started, the total voltage left in the system is supposed to equal to 0. So using that, we can say that for loop A, we're gonna start like right here. So we have the voltage used up by each resistor, which is the current times the voltage. So we have negative 1 times I1 minus 1 times I2, then minus 3 times I1. And then when you go through a battery, you add the voltage if you go in through this side. So plus 2 is equal to 0. Same thing for loop B. So we have negative 3 I3. We're just going to start right here for loop B. So we're going around here. So negative 3 I3 minus 2 times the current going through this, which is I1 minus I2. And then so for this one, since we're going against the green arrow, we're going to add it instead of subtract it. So plus 1 times I2. And then plus 2 equals 0. So then for loop C, we're just going to start right here. So we have negative 2 times the current going through that, which is equal to I1 minus I2 minus I3. Okay, so this time, since we're going into the positive side of the battery, we're going to subtract the voltage of the battery. So minus 6 minus 4 times the voltage going through there is I1 minus I2 minus I3. And then add up right here, so plus 3 I3. And that is going to equal 0 again. So now we're going to simplify all of these equations that we have written out here. So this one's going to go down to negative 4 I1 minus 1 I2 plus 0 times I3 is going to equal to negative 2. Right here we have negative 2 times I1 plus 3 times I2 minus 3 times I3 is also going to equal negative 2. And right here we have negative 6 I1 plus 6 I2 plus 9 I3 is going to equal 6. So now this right here is part of linear algebra because you can set up this equation as an augmented matrix, which we did a lot first semester. So you're going to see that right down here. We're going to get a new sheet of paper and we're going to transfer over this matrix. So we have, and remember, when you do an augmented matrix, the first column is like saying I1, and the second is like saying plus I2, then plus I3 is equal to whatever's in the final column. So now we are going to have negative 4 right here, negative 1, 0 equals negative 2, negative 2, 3, negative 3, negative 2, negative 6, 6, 9, 6. So first thing I'm going to do right now, just to make it a little cleaner, is I'm going to multiply each row by negative 1. So row 1 times negative 1, row 2 times negative 1, and then row 3 times negative 1. And that is going to give us the matrix 4, 1, 0, 2, 2, negative 3, 3, 2, 6, negative 6, negative 9, negative 6. Now I'm just going to swap out these two rows over here. So that will make our new matrix equal to 2, negative 3, 3, 2, 4, 1, 0, 2, and then 6, negative 6, negative 9, negative 6 again. Now, remember, when we want to bring this to row echelon form, the goal is to make each one of the columns have a leading 1, and then underneath that only zeros. So to make this a 0 right here, we're going to have row 2 plus negative 2 times row 1, because negative 2 times row 1 is negative 4 plus 4 is 0. That's going to replace row 2. Then we're going to have row 3 plus negative 3 times row 1 for the same reason is going to give us the new row 3. Now, if we bring that down here, you'll see we are left with a 2 right here. Remember, 2 times negative 2 gives us negative 4 plus 4 is 0. 2 times negative 3 is negative 6 plus 6 gives us 0. And then we don't change row 1, so we can just write this in. Okay, and then you can just follow the math for the rest of it. So for this one, we will get 7, negative 6, negative 2, 3, negative 18, negative 12. Now the next thing we're going to do is we're just going to divide this row by 2 because we want a 1 out here. So row 1 times 1/2 will give us 1, negative 3/2, 3/2, and then 1. And we didn't change any of the other rows, so we can just write those over here. Negative 18 and then negative 12. Okay, so the next thing we're going to do, we're going to try to get this a leading 1, so we're going to bring this number down to 1. So we can do that. 7 minus 6 is 1. So if we do row 2 plus negative 2 times row 3, then make that equal to row 2, we'll get a leading 1 out here because negative 2 times 6 plus negative 6 plus 7 is 1. So that makes our new matrix 1, 0, 0. We didn't change row 1, so we can just put that in. And we also didn't change row 3, so we can just put that in. And then right here, so we're going to be left with 1, 30, 22, which is kind of messy, but okay. For the next one, we want to bring this down to 0. So if we take row 2 and multiply this 1 by negative 3 and add that to this 3, we're going to get 0. So we're going to have row 3 plus negative 3 row 2 is going to equal row 3, and we'll draw this down here, make sure I'm still in the frame. Okay, so now we're going to have row 1 we didn't change. Okay, then row 2 we also did not change, so that's still 0, 1, 30, 22. And then down here we're going to have 0, the other 0 that we just eliminated, negative 108, and then negative 78. Okay, so this is pretty sloppy right now, but we're going to multiply row 3 times negative 1 over 108 because we want a 1 right here. So that's going to make our new matrix 1, negative 3 halves, 3 halves, 1. 0, 1, 30, 22, and then 0, 0, 1, and then 13 over 18. Okay, now remember what we wrote up here. So this is equal to I1 plus I2 plus I3 equals. So now we can bring out this equation right here and say that, I'll do this in red, say that 0, we're using this row right here, 0 times I1 plus 0 times I2 plus I3 equals 13 over 18. So now from this we can say that I3 equals 13 over 18. Now if we take up this second row, so this one's here, if we take up this second row, bring it down here, so we can have 0, I1 plus I2, then plus 30 times I3, which is right here, so we'll do 30, bring that in parentheses, so 13 over 18, which is what we found I3 equal to, and that is going to equal 22. Now if you simplify this, we get that I2 is equal to 1/3. Okay, now we do the same thing over here, bring this one down, so we have I1 minus 3/2 of I2, which is 1/3, plus 3/2 of I3, which we found to be 13 over 18. That is all going to equal to 1. Then when you simplify this, we get that I1 is equal to 5 over 12. So now, oops. Okay, so now we know what all the currents in our original circuit are equal to. So if you look over here, you can see this was our original circuit. So I1, which is flowing through right here and down here, we said that is equal to 15/2. So now since we know that, we can put our unknown resistors into the circuit and then test the current going through this wire. And if the current going through this wire when we have the unknown resistor in place is equal to 5 over 12, then we know that we have the 3 ohm resistor in there.
Now he can start testing resistors to see which one has the right current. It's important he gets the right one because if it's too high or low, it could fry the circuit and lock him in. This first resistor he tries, the current isn't correct, so he tries the second, and this time it is correct. So if he did all his math right, he should be able to open the door. When he gets in the hallway, he realizes he can't go downstairs out of his house because the fire, so he grabs a box and a ball to throw one through his window. He wants to throw whichever one weighs more because it has the higher chance of breaking the window, so he figures out the mass of both objects.
As you can see, I drew it right here, and we have x is 0 to 2, y is 0 to 2, z is 0 to 2. And here's the density function. It is 4x to the 5th y, and it's in grams per inch cubed. And as you can see, our x and y axes are set up with the one being 1 inch. So to find mass of a solid, you take the triple integral of the area of the density formula of the area. Okay, so let's set up that function right now while we have it out. So we take the triple integral. Now since all these are going from 0 to 2, we can just write those in right now. Okay, now we do that. So 4x to the 5th y plus y e to the x z plus z cubed dx dy dz. Okay, now all we have to do is solve this and we should have the mass of our solid. So here we have this integral over here, and then so first step, integrating with respect to x. Make sure I'm still in frame. So 0 to 2, 0 to 2. Now the integral of this with respect to x is 2x to the 6 divided by 3y plus y e to the x zx plus x z cubed from 2 to 0, and then integrate that from dy dz. So you plug in the 2 and then subtract plugging in the 0, but since every single one of these terms has an x in it, when we plug in 0, we're just going to get 0. So we can skip that step. So if we plug in 2 into each one of these, we get 128 over 3y plus 2yz e to the 2 plus 2z cubed dy dz. Now we integrate this with respect to y. So 0 to 2 of the antiderivative of this with respect to y is going to give us 128 divided by 6 y squared plus y squared z e to the 2 plus 2z cubed y. Plug in 2 and 0, and again, there's a y in each one, so the zeros will cancel out, so we don't have to worry about that. So we get the integral of 0 to 2 of 256 over 3 plus 4z e to the 2 plus 4z cubed, and differentiate that with respect to z. Now let's see, we can finish it on this page over here. So now we bring this down. Now we just have the antiderivative of this with respect to z, which will give us 256 over 3 multiplied by z plus 2z squared e to the 2 plus z to the 4th. Then plug in 2 and 0 again. There's a z in each one, so we don't have to do 0. And this will give us an answer of 512 divided by 3 plus 8 times e to the 2 plus 16. Now this is roughly 245.78 grams. So that's how much our solid weighs.
So now I need to calculate the mass of the sphere. The sphere has a radius of 2, so the integral will be m equals integral from 0 to 2 of the density function pi plus r cubed dv. Now, volume of the sphere is given as v equals 4/3 pi r cubed. So in order to get dv, we have to take the derivative with respect to r. So we do dv dr equals 4 pi r squared. Then isolate dv, we get dv equals 4 pi r squared dr. So then we just sub it back into the equation, and we get the integral from 0 to 2 of pi plus r cubed times 4 pi r squared dr. And then we just integrate. And this value gives us 239.317 grams.
Now that the boy knows that the box weighs more than the ball, he can throw it out the window to break it. And he makes it outside just in time. When he's outside, he realizes the fire is spreading to his backyard. He has a hill in his backyard which he wants to climb at the steepest ascent. That way he can escape the fire the fastest.
Now we must calculate the path of steepest descent to get away from the house. The hill has a function given as e to the 1/2 x plus 1/2 y times cosine y times sine of x. In order to find the path of steepest descent, we must take the gradient of the function. And in order to do that, we have to take the partial derivative of the function with respect to x and respect to y. So we're going to start with respect to x. So we do partial with respect to x. Since we're doing it with respect to x, this value is going to stay constant. So we just pull that out front. and we worry about the rest. Now we just differentiate. When we plug in our initial point of 1, 1, we get a value of 1.41147i. Now I must do the same thing with respect to y. So we have the same function, so we just do partial f with respect to y. Now, since we're doing with respect to y, this value will stay constant, so we just pull that out front again and worry about the rest. And now we just differentiate. And when we plug in our initial point of 1, 1, we get negative 1.3068j. So that means in order to take the path of steepest descent, we get 1.41147i minus 1.3068j.
Now that the boy knows the fastest ascent up the hill, he climbs it and makes it just in time. He can wait there until a fire truck comes to put out the fire. Here's a visual aid of what the hill in his backyard looks like.